Welcome to Safety Chats. Host Jason Stark, Director of Safety at Baldwin Safety and Compliance, shares decades of aviation experience and a passion for safety. Let's get started with this week's Safety Chat.
So here's the question. What do clear air turbulence, thunderstorms, and extreme heat have in common? You're probably thinking, well, Jason, come on. I mean, seriously, those are all meteorological phenomena, and that would be correct. But those are the topics of today's short little podcast, which is more of an informational public service announcement, if you will. Hey there, it's Jason. This is the Baldwin Safety Chat podcast. This is where we talk about everything safety, safety management, organizational behavior, organizational excellence, you name it. Anything that can potentially help us to do our jobs just a little bit better. I love learning from you. I hope maybe you learn something or scratch your head on a few things from me. That's always a wish of mine. Don't always know if it happens, but this is one that has come to mind, I must say, over the last few weeks. We've seen a lot of news, and I think it's a little bit sensationalized, but we've seen in the news the turbulence in the Singaporean Airlines incident, and then there's been another incident where people were injured from turbulence, and then we've seen the power of some of the storms that have come through, certainly the central Midwest of the United States. And then the heat. We're headed for some extreme heat, especially down here where I'm at in the southeast. It is a little toasty for this time of year, if I may say. Generally in May, we're not reaching heat indices of 105 degrees, but you know what? This is Houston, so what can I say? It has nonetheless made the news, so it seems like the news people latch onto whatever they can, especially to sensationalize a particular issue, I think, to get ratings. Let's take each one of those topics, and I'll try to be brief if I can. Let's start with turbulence. Turbulence has always been something that has bothered me. And turbulence is not a new phenomenon. We have had turbulence in the atmosphere since the world came into existence. There's no getting around it. It didn't become a hazard until we started flying at the level of upper atmospheric currents back in the 1940s when we started getting to those higher altitudes with the bombers. But here's the thing, it's always been up there, and it is those currents in the upper atmosphere that actually dictate our weather here on the surface. Now, you might ask me, well, Jason, how do you know this? And I'm sorry, this is way too fun for me to say, but I do have a BS in meteorology. I don't know. That kills me every time. It's true. There are upper-level currents or upper-level rivers, if you will, that meander and as a result create the weather down here on the surface. Some of those meanderings are just like a river that you might look at from the shores if you're standing on the shore of the Mississippi River or even a small stream. You see how the water acts, right? So you'll see little swirls and whirls and eddies and little undulations if it's going over rocks. The atmosphere acts the same way. So, for example, let's say that you do have a jet streak, if you will, which is a core of very fast-moving air, surrounded by air that's not moving as fast. Well, guess what? There's going to be friction, which is going to cause eddies and little undulations, and that's going to affect anything that's flying through it. So if you imagine even the creek and you watch the little leaf going down the stream and you notice that there's a little eddy, well, that leaf is going to bounce around and swirl around, and it's no different than an airplane. And this, again, is not a new phenomenon. Now, I know there has been talk in the news about how turbulence is going to get worse with climate change. I'm not even going to touch that one with a 10-foot pole. But what we do see is that turbulence is strongest usually between contrast in temperatures, between warm and cool. That's where the winds are the strongest in the upper atmosphere, are between two contrasting air masses. So there's always going to be turbulence, but when you have really cooler air and relatively warmer air that are right next to each other, upper atmospheric currents are going to be stronger, therefore you're probably going to have more turbulence. And if you ever want to find turbulence or where there's a potential for turbulence, there's a couple things you can do. Go ahead and grab yourself a 200 millibar chart. That's 200 MB chart. And take a look And especially if you're flying jets, you're up at that altitude, or if you're flying turboprops, take a 500 millibar chart. And when you see a trough in the atmosphere, and I want you to picture a trough. So if you picture the United States, something that looks like a U going over the United States, and I'm sitting here drawing like you could actually see me, but I'm drawing my finger, but like a U, like a trough, like you imagine in a graph, in a sine wave, a trough. And if you look at the bottom of that trough and you go to the east of the vertex of that trough, that's where you're going to find generally most of your turbulence. And that's where you'll see the jet streak, and that's where you'll see a lot of the swirls and whirls. And on that east side of the trough, east of that vertex, that faster moving air, that jet streak moving through that trough is what helps create our low pressure systems that we see on the ground that bring the warm air up from the south and the cold air down from the north. But that's getting into a little bit more advanced meteorology, but that's one place to look. Also, if you just look at a jet streak, which is an area of very fast-moving air, if you look at the front right quadrant and the rear left quadrant, that's generally where you see a lot of turbulence as well. That's where you see a lot of the greatest friction in terms of the upper atmospheric air. So you have something very fast. So a jet streak, anything moving like 120 knots. And then it's contrasted against maybe air that's moving 90 knots or 80 knots. Well, that's going to create some undulations, and that's going to create a little bit of friction, and you're going to get some bumps. There's no doubt about it. And then another place to look is in the Great Rocky Mountains. Now, if you have a pretty good upper atmospheric flow, say of 50 knots or more, that is within 30 degrees perpendicular to the Rocky Mountains, well, you're probably going to have mountain waves. And just like waves in an ocean, those mountain waves can crash. And when they crash, they create a lot of whirling and swirling and turbulence. And so you got to be careful when you're on the lee side of the mountains, again, within 30 degrees of perpendicular to the mountains, and 50 knots or greater. But a lot of it depends on the upper atmospheric temperature profile. But let's just say, to be safe, if you see winds 50 knots or more within 30 degrees of perpendicular to the Rocky Mountains, then you're probably going to have a little bit of turbulence. So why am I talking about this? Because as we know, turbulence, we can guess that there's going to be turbulence around forming storms. And we see that and we're like, okay, there's going to be some bumps. Let's avoid it. But the big thing is clear air turbulence. A lot of times you can't even see that. Now, what I just gave you was some of the signs of where there may be clear air turbulence. And there's a few more, but I won't get into them. What you want to be aware of is that if you start getting bumps in the clear air, chances are it can get worse. And what really concerns me is that the seatbelt sign in corporate aviation aircraft seems to be more of a suggestion. And especially when you don't have cabin crew in the back to direct the passengers to fasten their seatbelts. Now, there have been many times when I've been flying and we've been going through turbulence or turning the seatbelt sign on, and the passengers are still up with their glasses of champagne, walking around, doing whatever. They haven't taken a seat. And that goes to a situation that can become very dangerous. People can get hurt. Early in my career, when I was an air medical pilot, I had to air evac a flight attendant out of Denver whose aircraft had hit clear turbulence over the mountains, like we were talking about, and who had been thrown into the ceiling and broke her back. And so we had to air evac her out of Denver to a medical center where she could get treatment to repair and heal her back. So clear turbulence is no joke, and it can create lethal injuries. So we need to be cognizant of that. And I don't know how we do it, and maybe you have suggestions, but how do we educate the passengers that just because you're flying a corporate jet and you don't have the quote-unquote militaristic cabin crew of airliners breathing down your neck, going down the aisles and checking to make sure that your seatbelts are fastened, and they're not calling you out on the intercom. And you know what I'm talking about, because there's always that guy or that gal that when the seatbelt sign is on and you're going through some bad turbulence, they'll invariably get up and have to go to the restroom. And then there'll be the announcement while that person's walking down the aisle saying, we need everybody to be in their seats, seatbelts fastened. The captain has turned on the seatbelt sign. We're taking our seats too. There's always that guy or that girl. So you don't have that in corporate aviation. So they don't have the oversight. So how do we educate the passengers to ensure that, hey, when we turn that seatbelt sign on, it's not a suggestion, it's for your safety. Now, they probably know that in the back of their mind, but it's not enforced. And this is something that really concerns me because people have gotten hurt seriously and killed, not only in airlines, but also in business aviation due to wake turbulence or clear air turbulence. So that's number one. Number two, thunderstorms. Thunderstorms are no joke. That's another hazard that we face. And obviously in flying, we know to steer clear. We give them a wide berth. They're not fun. They can spit hail up to 50 nautical miles. Lightning is nasty. Wind shear, turbulence, all the good stuff. Heavy rain, virga, which is a topic for a completely different podcast. But that's all related to thunderstorms. My concern is on the ground. And the reason why I say this is that we have to take care of our ground crew. And when there is a storm within 5 to 10 miles, we need to get them off the flight line. You know how hot a lightning strike is. And I'm not talking about the electric jolt. I'm talking about the heat. And even when you're within 100 feet of a lightning strike, it's pretty darn hot. So we need to protect our ground crew that they cannot be on that ramp when there is a thunderstorm within the vicinity. Everything needs to be shut down. I'm not really concerned about fuel vapor igniting. I'm not really concerned about aircraft getting struck. I'm concerned about the person. Because if an aircraft is struck and that person's near the aircraft, well, the aircraft is a great conductor of that electricity, conductor right through the tires and the static wicks. And if there's a person sitting underneath that aircraft, well, guess what? They're going to probably get some of that juice. And it's not going to feel good. And if they're out on the line and they're struck near, there's a strike. And we've seen the videos. So if you go on YouTube and you look at lightning strike on the ramp, I think it was the American Airlines ramper, but it was within 50 feet and that person just keeled over. They didn't die, but they were seriously injured. You have to be careful of that. And what makes me think of that is that probably about 3 weeks ago, I was coming into Houston on a flight, and we were dealing with thunderstorms left and right. And we just happened to land at Houston before a major thunderstorm rolled through. And of course, we're all down in luggage, and we were late. It's like 2 a.m. We're already like 4 hours late because of delays, because of thunderstorms, and everybody's crabby, and everybody is tired. And then we get the announcement, well, your baggage is going to be delayed because the ramp has been shut down. And some of the things that people said really concerned me. They're like, so what? They're just being weak. They're just being wimps. And these people had no idea of the risk of being out there. And I want to convey that to you as well. That when you put people out on that ramp, a big open space, and in some cases they're probably the tallest object within a quarter mile, we need to be careful. And we want to get them inside, we want to get them safe, and wait till that thunderstorm is well passed over, at least 10 miles away, before we stick them back on that ramp. And so that's thunderstorms. Now let's get into heat. Heat is just about as big a killer as turbulence and as thunderstorms. And I can say this from, almost firsthand experience, but as many of you may know, my wife is part owner of CrossFit gym. And in the gym itself did the Murph exercise on Memorial Day like they do every year. Murph is a pretty intense, if you don't know what's all involved, it's a run, pull-ups, push-ups, and squats, and then another run, and generally people do it with a 20-pound vest. And CrossFit gyms are not usually climate controlled. So here in Houston, it is warm. Yesterday, the heat index, Memorial Day, the heat index was probably about 106, maybe a little bit hotter inside the gym because there's not as well as ventilation as outside. But I was there delivering ice, bringing some more ice for the towels and the Gatorade. And naturally, when I pulled up, there's an ambulance there and somebody had overheated. And they turned out to be okay. They stayed the night in the hospital, but we need to be careful of our workers out there, especially with high heat indices. If you're in the south or southwest or even the west, but wherever there's high heat indices, wherever there's a lot of heat, we need to be careful. Now, high temperatures are one thing. So they always say a dry heat out in like Phoenix or something like that. And there's something to that. A dry heat is a little bit different than the heat that we might experience in some of the Gulf Coast states, so Florida, Mississippi, Alabama, Texas. So the difference being that when there's a lot of moisture in the atmosphere, that obviously bumps up the heat index. But what happens is that what's called the moisture gradient in the air is very shallow. So that means water does not evaporate quickly or sometimes even at all. And what is the problem with that? Well, evaporation of water takes heat. So when you sweat, it actually takes heat to turn that water into vapor to put it into the atmosphere. Now, if there is a steep moisture gradient, i.e., if the atmosphere is dry, that evaporation is going to be very efficient and it's going to happen very quickly. Therefore, your body will cool more quickly. So, as soon as you sweat, the heat from your skin is used as energy to evaporate that water, and that water goes into the atmosphere as vapor, and in the turn, the temperature decreases at that surface by a few degrees. And that's the whole purpose of sweating. That's why we sweat. It really helps us to cool down. And that's why the blood goes towards our skin to help cool it down, and so on and so forth. And you guys all know the physiology behind heat. Well, again, with high heat indices, if there is a very weak evaporation gradient or water gradient, then that moisture is going to sit on the skin and it's going to collect, and it can actually act as an insulator, which is no bueno, as we say down here in Texas. And your body is going to continue to heat and heat and heat up until eventually you're going to start hitting heat exhaustion and eventually heat stroke. And that's what we want to be careful of. So when we're putting people outside in these hot temperatures, and it doesn't just happen in the Gulf states, it's happened in the Midwest. In fact, I was part of a study for higher dew point temperatures. Dew point's the measure of the humidity within the atmosphere. There have been higher dew point temperatures in the Midwest across Iowa and Chicago. And my theory was that it was due to the corn, but if you want to hear more about that, more than happy to talk with you that on the side. But dew points have been higher, and that's why we've had some of the record heat waves in Chicago in the last 2 to 3 decades. So we need to be careful with that because our sweating becomes less effective and less efficient, and people's core temperature will heat up dramatically, and we need to be careful of that. When you send people outside during the summer, don't just look at the temperature. You might say, it's only 91 degrees. Well, you may have a heat index of about 110, 120 degrees. So you need to look at that when you're sending people outside to work, and when you have those high heat indices, and I would argue anything over 90, 95 to 100 degrees, I would work them in shifts and make sure they have plenty of water and a way to cool down quickly. If somebody does start showing signs of heat exhaustion, get them in the shade, get them in a cool area, wrap towels around their neck, and as I learned, I hope this is appropriate for the podcast, but put cool towels in their groin area because that's where a major artery is carrying blood. So you want to cool them down as quickly as possible, because what happened to this individual, his liver and his kidney started shutting down. And like I said, he's okay. He's been restored to complete functionality of his liver and kidney, but there have been stories of CrossFitters and other gyms, not ours, that have gone into complete heat stroke where their liver and their kidney shut down completely, which now has precluded them from working out to any sort of exertion in the heat now in the future. So that it was permanent damage to his body. So we need to be careful of that. We need to be careful of our folks going out there in the heat. We need to watch over them, make sure they're safe, and make sure they're cool. So there we go. This has all been about taking care of people and serving other people. First of all, our passengers and cabin crew. Clear air turbulence is a killer, and we need to watch out for it. I gave you some signs of where clear air turbulence can exist. I recommend that you grab yourself, you just go to the Aviation Weather Center, you get yourself a 200 millibar map or a 500 millibar map, take a look at how the atmosphere is flowing, and I gave you some tricks and tips of where to look for turbulence. Then we talked about thunderstorms, specifically thunderstorms and their interaction with rampers. People out on the ramp doing workout on the flight line, we want to be careful of that. We want to keep them safe. We want to protect them from not only lightning strikes, that's the worst, but high winds, hail, all the elements, all the fun stuff that go with severe weather, especially the winds. I'm not worried about somebody getting blown over as much as I am the wind picking up a pair of chocks and launching it at somebody at 50 knots. That would not feel good and could leave a mark. We want to be careful of our folks out there on the ramp, especially during thunderstorms. Thunderstorms within 10 miles, get them inside get them safe, shut down that ramp until that thunderstorm passes, make sure everything's secure before you get everybody inside, because obviously first priority is the people, but you also want to look at the equipment and the aircraft out there as well. So get everything secured, get them inside, wait till the storm passes, and then continue on with your day, probably in cooler temperatures too, which the people will be thankful for. Which takes us to our third point, is heat. Heat is also a killer. So when we have those heat indices way up there in the upper 90s and 100s, we have to be very careful of our people working outside. Rotate them out, get them inside as much as you can, make sure they have plenty of fluids, plenty of water. Gatorade, pop's probably not the best thing, or as everybody else in the world says, soda is probably not the best thing. But get them plenty of water, plenty of fluids, make sure they're in a cool spot if they start overheating, and just keep them safe. So I hope this was helpful. Again, this was more of a public service announcement type of podcast, but I just want to put this on the front of everybody's mind as we go into the summer season. There's a lot more fun to come with the summer in terms of weather when we talk about hurricanes and severe weather and droughts and all that good stuff. Don't even want to get into that. I want to talk about the two things that are specifically deal with summer. Turbulence actually gets worse during the winter and relaxes during the summer, but it's still a big factor. It's something we should always look out for. So I hope this helps you at least scratch your head and start thinking about things, and I hope it's of some use to you. Thank you so much for listening. Thank you so much for what you do. You guys are doing a tough job. You're out there towing the line of safety. Sometimes when people don't even want to hear about it, they just want to get the job done, right? I don't want to sit inside the ramp. I got 3 more planes to fuel. Well, you know what? I care about you. You're going to sit inside. I don't want to buckle my seatbelt. I'm paying $1,000 a minute for this jet. I should be able to walk around. Well, you know what? We want you to arrive in the location in one piece. I don't want to sit down and not tow that jet. You know, it's only 100 degrees outside. Well, you know what? You exposed to that, it's put your life in danger. We want to keep you inside. We want to make sure that you're not out there too long. This is about taking care of people. I hope this was helpful. If you guys have any suggestions or recommendations of anything you want to hear, please let me know. We've got some good topics coming up, and I'm excited to drop those to you. And as always, I love you guys. Thank you so much for what you do. And until I see you in the next podcast, stay safe.
This podcast is brought to you by Baldwin Safety and Compliance, the leader in safety management for the transportation industry. Since 2004, Baldwin has been providing state-of-the-art solutions and 24/7 support to the aviation and transportation industries. Baldwin's clients include all sizes and types of transportation operators. Baldwin provides safety and related business services to commercial and non-commercial transportation operators, medical transporters, FBOs, MROs, airports, flight schools, UAS operators, firefighters, OEMs, ground transport operators, and others. Visit BaldwinSMS.com to discover how Baldwin can enhance your organization's safety program.